Hi everyone, this is a reflection video for POGIL 4, the POGIL exercise that we did in class ending on September 13th. This one dealt with the F-test, which comes out of chapter 4.4 in your textbook. This again deals with determining whether the variations or standard deviations between two data sets or sample sets are different. So hopefully y'all can follow along. I'm going to just quickly summarize what the take-home message was from our F-test and also go through a quick practice problem. So again, this is from our most recent POGIL, POGIL 4. Alright, and so just to give you some context, we finished up with our last POGIL exercise. We were talking about the t-test in these three different cases. Case 1, which is measured value, where the question you're trying to answer is a measured value different from a known value. Case 3, we see here are two sets of paired values different. So hopefully you all know how to apply those. And case 2, which I said is the most commonly used one, is our two measured values different. And I want to bring up this case of the F-test because actually it's a little more complicated than I originally showed you. Again, case 1, we use this equation. This is your measured values, this is your known value. Case 2, you look at the differences between your paired values. Case 3, you look at the differences between your paired values and the standard deviation of those differences. But case 2, what we found out in class was that it's actually there's two different equations to use, and it's going to depend on the situation. So there's a couple different situations. You can assume that the variances are equal between two samples, right? And just remember, variances are just the standard deviation squared. So we're assuming the variances are equal, and also that the standard deviations are equal. That those would go along with each other. In that case, you use this t-calc here to determine your t-calculation, and there's a special pooled value for this. We went over that in t-test, or in the POGIL exercise, the last one, POGIL 3. Whoa, what just happened there? And then our recent one, and we also have this other situation where if you're assuming different variances. Okay, so the question, of course, we might have now at this point is, are the variances different? How do we determine this? And this is where the F-test comes in. As we went through in our exercise, we saw that the F-test uses the ratio of your two variances. And so if you remember, your S squared, this is your standard deviation, equals a variance. Okay, so again, that's variance, and this is your standard deviation. And so hopefully you remember, I remember a number of you asked me when I was introducing the concept of variance before, why is variance important? It turns out a lot of the statistical equations that we use rely on variance, and so it's important to rely on variance. It's important to know what that is. So you simply just square your standard deviations to get the ratios of your variances between two samples, and you determine your F-calc. And you compare it to this table. And there's one thing I did want to mention that we emphasized in our POGIL exercise, and that is, right, you look here, your largest value is always on top. Okay. So if you're having two samples, you put the one with the largest standard deviation and therefore the largest variance on top. So you'll notice that your F-calc will always be a value greater than 1. And that will make sense when you look at this table, because as you notice from the table, every one of these values is greater than 1. All right. And so in this case, you look at it because both your samples could have different numbers of measurements or different numbers of values. Each one of them is going to have their own degrees of freedom. Okay. And so you want to look at, this is the degrees of freedom for S1 in this case, we're talking about the numerator, and S2 on this column here, this is your degrees of freedom in your denominator. And as we've seen before, if your F-calc is greater than your F-crit, or your F-table, then variances or standard deviations are different. Alright, so this is just like we saw with the t-test or the Grubbs test, right? You have this critical value table, and if you calculate, we have a calculated value that you get from your actual data, and if that calculated value is greater than critical value, at the degrees of freedom that you're looking for, then in this case, the variances are different. Okay, so we're going to go back to this problem that we looked at. This is the third time we've looked at this now. In this case, we're looking at some data where we're trying to measure some marker for DNA damage. And that marker is measured in terms of lesions per bases. Alright, and so we have a negative control, so one that's not been exposed, and one that has been exposed. And so the question we're trying to figure out is, do nanotubes cause DNA damage? Alright, so the first thing you might look at when you look at these two is you might just intuitively notice that the standard deviation of your nanotube exposed is larger, significantly larger than your negative. Alright, so now we want to determine whether these variations that are standard deviations, which appear to be different, are actually different, and that will determine what form of the t-test we want to use. And so in that case, if you remember our formula, right? Oh, sorry, I just want to show this picture again. This is a picture of that. This is what our data looked like from our previous example where we plotted it, trying to show what the Gaussians might look like. And you can see here from the Gaussians that these look like pretty different standard deviations. But we're just going to test that using the f-test to verify. And so what we're going to do is we're going to use our f-calc. If you remember, that is really just the standard deviations, the ratio of the standard deviations, right? Which is also the same thing as saying the ratio of the variances. And again, we always want to use the largest one on top. So in this case, use a different color here maybe. So our S1 is going to be our largest one, and that is 2.51. And our S2, smaller one, and that is 0.66. And so all we do is simply plug those in here, and we get 2.51 squared over 0.66 squared. And the answer to this is 14.5. Right? So this is our f-calc. So f-calc equals 14.5. So we want to find out what our f-table is. And so we look back at our table and we remember that there are 5 observations in each. So that means the degrees of freedom is n-1 and f. So for each of these, this equals 4. Okay. So you go to the degrees of freedom in your numerator is 4, and degrees of freedom in your denominator is 4. So where these overlap, this is your or your f-calc, or your f-critical, sorry. So f-critical equals 6.39, and so since our f-calc is larger than our f-critical, so f-calc, in this case, it's fairly significantly larger than our f-critical. Therefore, the variances or standard deviations are different. So in that case, what we want to use is the t-test here, which assumes different variances. Okay. Okay, and so in that case, we use this form of the equation. T-calc equals, you got the difference in your x values over square root of S1 squared divided by n plus S2 squared divided by n. So if you remember, x1 equals, we're going to call this 5.51, and our S1 equals 2.51, and our, so that should be n1 and n2. N1 equals 5, okay, and then our x2 equals 4.24. Our S2 equals 0.66, and our N 2 equals 5. Now we just need to plug these numbers in. It's green again. So this equals 5.51 minus 4.24. These are absolute values. So your numerator and your denominator is square root of 2.51 squared over 5 plus 0.66 squared over 5. Right, so you get this in your t-calc equals 1.09. Okay. And so this where it gets a little bit trickier in terms of the t-test for this using this form, because the degrees of freedom in this case are not obvious. And we said that's because we know that the variables are not, all the measurables are not necessarily independent, because the standard deviations are somehow related to the mean, right? They're not independent of those means. And so in order to determine the degrees of freedom, we use this formula here, and I'm not going to go through and plug it all in for you, but maybe you can try it on your own. But our n degrees of freedom equals 3.4. Alright, and I sort of told you as a quick rule of thumb, it's usually around half of what the other degrees of freedom were. And what the degrees of freedom would be if it weren't, if we weren't calculated by this manner. But if we look at our table, our t-table now, we want to figure out if our t-calc is greater than our t-critical. And our degrees of freedom are actually 3.4, which you notice is not a whole number, so it's somewhere between 3 and 4. And in general, if I don't give you a value, a confidence level, we're looking at 95% confidence level, so it's 3.4. It's somewhere in between 3.182 and 2.776, okay? So since it's kind of close to being halfway in between, it's roughly halfway in between those two, so it would probably be around 3.0. But it doesn't really matter for this case if we look back. So this is our t-calc, right? So t-calc equals 1.09. T-critical is around 3, but we'll say it's around, it's somewhere between 2.7 and 3.3, somewhere in between those two. You notice it doesn't matter even if it's 2.7. Either way, no matter what, t-calc is going to be less than t-critical. So in this case, if t-calc is less than t-critical, that means that these are not different. All right. So just keep in mind, what we're comparing to here are the means, right? This t-calc is based off of means. It's a comparison of means. So that's saying is that this mean here is not different than that mean there. So if we go back to our original question, which is, do the nanometers cause DNA damage? Our answer would be no, or at least not from this experiment. Okay. So with that, I'm going to wrap up here. Again, that is from Harris, chapter 4.4, and that is our reflection on the 4th POGIL assignment. So in the links connected to this, you're going to see the peer evaluations and your analyst reports, so please do fill those out and get a chance. And I will see you in class on Monday.